This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 76, a review of what is new in Ansys Mechanical APDL 2020 R2, and an update on what is going on in the world of Ansys. Greetings, I'm Eric Miller, one of the owners here at PADT, and welcome to our podcast. I'm broadcasting live from my backyard. My trusted assistant, Mo, who is a Black Lab Shepherd mix, is assisting me by making sure the birds don't get too close. Actually, he's passed out on the patio right now, but that's his job if he chooses to do it. It is mid-November, which is warm time here. It's cool enough to go outside here in Phoenix, so we're enjoying our backyard. We've successfully made it through Friday the 13th. 2020. I'm not a superstitious person at all, but I was a bit nervous all day on Friday. Here at PADT, we are buckling down and reinvigorating our attention to detail and safety. Our existing personnel, our essential personnel, and a few people who prefer to work in the office are in our Tempe headquarters, and the rest of us are settling down probably to work through the winter at home. The secret we have found, at least with my team over in the consulting side of things, is to make sure we take time to talk to each other as much as possible. On the design side of things, we usually have our cameras on and we share our screens, and it's a very interactive process. Our simulation consulting team, and let's be honest, many of us enjoy our careers in simulation because it doesn't require a lot of human interaction. We still try and take the time to talk and share our work. Even if we don't turn the cameras on and we are meshing, plotting, and watching conversions while we are chatting, we'd make an effort to try and get together as often as we can and just get that human interaction going. I'll just ask that everyone who listens to this podcast, please be safe out there. The numbers don't look good, and if those of us who are in simulation know it's just math. We need to be safe and at any chance possible reduce the probability of transmission. And we would really like everybody to stay safe because we need you in our Ansys community. So today we're going to talk about what is new in Ansys Mechanical. This is the program originally called Ansys that started everything, really. If you have not done so, please take a listen to the interview with John Swanson, the founder of Ansys, and the original author of the tool we will talk about today. That's episode 35 in the archives. What is amazing is how this code has grown and continues to improve with every release, and they add more amazing capabilities to it all the time. And speaking of which, let's catch up with Ted Harris and find out what his favorite additions are in the most recent version. I want to welcome everybody again to another discussion of new features in Ansys 2020 R2. And today I am joined by Ted Harris, who is going to talk to us about some enhancements to MAPDL, which, if you don't remember, is the solver behind Ansys Mechanical. And sometimes some of us use it still on a standalone basis. And we're going to talk about what his favorite things are with context and solver updates, as well as elements. So welcome, Ted.
Well, thank you, Eric. It's good to be on the podcast with you today. So your introduction reminds me, just yesterday, one of our colleagues who's not on the technical side of Ansys, when I told him I was going to be doing this podcast on Mechanical APDL, said, well, for Mechanical APDL, do they bring the enhancements in a DeLorean? So the reference was to the Back to the Future movies, and maybe we're going back to the 1980s or 1990s or something. And I said, well, you have to realize that, as you said, Mechanical APDL is what writes the solver file that is solved when you're solving an Ansys Mechanical. So another way to look at it is Ansys Mechanical is a pre- and post-processor for the Mechanical APDL tool.
Right. Yeah, it's still a very viable and very used. Don't necessarily get into the user interface all the time, although I was in there last week doing some weird stuff with results files to, hopefully we'll talk about it in the future, to color 3D print results. But it's still there and it's still used every day, every time you hit the solve button, right?
Yeah. I was just on a meeting with some customers this morning, and they do have some applications where they are using it. So the need to use it is certainly much, much less than it had been, 5 years ago, 10 years ago, 15 years ago, but it is still there and available. And there are some nice things that we can do. And the other thing I pointed out to our colleague is that some of the enhancements that end up in mechanical go into mechanical APDL first.
Right. Especially on the solver element side, right? You can't, if you want a new element capability in mechanical, it's got to go into APDL first. So mechanical APDL first. So, yeah, cool. One thing I did is I forgot, if most people who listen to the podcast know who you are, but why don't you explain a little bit for new listeners, what your role is at PADT and your background?
So sure. I manage our group that provides Ansys support, also training and mentoring, pre-sales in the Ansys products. I've been at PADT for 21 years and been an Ansys user. I think this month it's, longer than I'd care to admit.
You're in the 30s now. Yeah. It's cool. It's still very cool. So what I really like to do with these, you're going to be talking in detail about the enhancements, but I like to kind of, for our listeners, talk about, the 3 or 4 things you really like about the new release in 2020 R2. So why don't you let us know, your top 3? What do you really enjoy seeing in there, or think is going to have a lot of value to end users?
Sure. Well, our customers are seeing more of a need for calculations in thermomechanical fatigue. Lots of devices out there have issues with cyclic stress and strain along with temperature effects. So a lot of automotive applications, aerospace applications. And, as companies are developing products, and, a big emphasis is trying to get costs out. What ends up happening is there can be issues with fatigue life. And I'm sure we've all had products that we've maybe not failure due to thermomechanical fatigue, but, they just break. And you're like, oh, why couldn't they just spend a little bit more money and make the thing a little bit more robust? Well, the idea here is that with simulation, we can make the products more robust before they make it into the hands of the customer or into the environment that they're going to end up in. And so Ansys has spent a lot of effort in the last few releases really trying to enhance the capabilities in thermomechanical fatigue. And the big one here in this release is a new tool for material property fitting, material data fitting. And so the various plasticity models can be curve fit using a new capability in mechanical APDL. Right now it's in mechanical APDL. I'm sure that it'll make it into the workbench interface before too much longer. But as far as the material models enabled, Chebosh kinematic hardening, bilinear isotropic hardening, rate-dependent plasticity with the Pierzina, Pierce, and EVH models, also kinematic static recovery, isotropic static recovery, isotropic elasticity. So those material models aren't new. What is new is the ability to do curve fitting for them. And it's beyond just that, because they have incorporated some artificial intelligence into this tool to help with the initialization of those parameters. So rather than us as engineers trying to come up with how to initialize constants or other quantities like that, the tool has some AI built in to help with that. So that should make it faster and more accurate. So that's.
I want to go back to the AI part. I didn't realize that. So we're starting to see it sneak in different places. I didn't realize they were doing that. That's pretty cool.
Yeah.
I'm excited about that.
Yeah, it's great to see an application like this come to fruition. And so
go ahead.
I have another one that's related to that, and that's also in fatigue life calculations. The ability to do what Ansys is calling cycle jumps. And so the idea here is that during the course of multiple cycles, so maybe the product needs to go through a load cycle of thousands of cycles up and down. And maybe there are, additional factors like temperature is going up or speed is going up or something like that. So the idea here is that the code can figure out, based on the past few cycles that it's calculated, what certain quantities like creep strain are going to do in the next few. So because it can sort of extrapolate those results fairly accurately, it will figure out, okay, it can jump a certain amount of cycles. And so that can reduce the calculation time in some cases by up to 40 or even 50%.
Wow. Okay. Big.
And so it's not a black box. I mean, the user has some control over how it does this. And so I think that's another really nice enhancement that is going to help our customers to develop more robust products in a faster way. And so that helps take cost out, which is what, a lot of manufacturers or all manufacturers are trying to do, but also sort of bring the robustness back. And hopefully that will help people like you and me that are buying the products not get frustrated when we've had premature failures, at least as far as, from our point of view, they happen.
Yeah, those of us that live in Arizona are always complaining that air conditioners don't have enough fatigue design into them, right? So we need to get those guys. Seems like they don't last like they used to.
I wasn't even thinking of that example, but that's definitely a very relevant one.
Yeah. So that's really cool. So kind of advanced things, taking doing curve fitting in a sophisticated way, including maybe even using AI, and then using kind of a standard cycle. The assumptions based upon what happens in that standard cycle, and using it to skip over similar cycles to get a faster runtime. That's pretty useful stuff. And again, these are in APDL, and a reason why it's good to know APDL if you need them now, and eventually they'll find a way to represent that in the mechanical user interface if people use it, right? So it's good. Cool. So those are both around lifing products. What's your third favorite thing in there?
Well, this one is not totally new at version 2020 R2, but it's the ability to use the PCG solver when we have MPC 184 elements present. Okay. So it used to be that you had to use a direct solver when you had MPC 184 elements, and MPC 184 is really a catch-all that does a lot of things. So joints, sliders, but also the multi-point constraints. And when they were present, you could not take advantage of the speed enhancements of the PCG solver. So now you can. And so again, this capability is not totally new in 2020 R2, but it has been enhanced at 2020 R2. So, we can go into some more detail next week when we do the Bright Talk webinar. But if you're using MPC 184 elements and you've been, by habit, using a direct solver, you don't need to do that. So give the PCG a try, and you may find that your solutions speed up quite a bit. And the resource utilization will be different as well. Probably get by with less memory allocated.
That's really good. So that's kind of a little thing, but and you may not even realize it. Again, if you're using mechanical, you may be defining a joint or something in your mechanical model, and under the hood, it's creating MPC 184 for some of those. And now you'll be able to solve that in PCG and get that faster runtime and everything, which is pretty cool stuff. Yeah, so those are all really useful things that it's funny when I look at these update slides, I'm always amazed at the variety that's in there. So there's a whole bunch more, which is a good reason to attend the webinar, both live or listen to the recording. I think that everybody will be pretty pleasantly surprised. And again, even if you're not an APDL user, it's always good to read the release notes, right? Those are still in the help, correct?
Yep. Yeah, they're very easy to get to. You open up the Ansys web-based help, and down at the bottom, there's a list of letters, groups of letters to click on. And if you click on the group that contains R, you'll find the release notes.
Okay, cool. Yeah, I always recommend that. Again, even if you're a mechanical user and not a mechanical APDL user, so you kind of know what's coming, and maybe there's a capability that you didn't know you needed, or did you know that was going to become available? And those are in the release notes, as well as attending the webinar, which is, I'm going to put you on the spot here. When are you giving that one, Ted?
Well, it is next Wednesday, which is what, the 18th?
I think so.
Of November?
Yeah, because the 11th is tomorrow. So good.
Yep.
Yeah. So pre-Thanksgiving, pre-Turkey Day webinar there, week before.
And while we're plugging the Ansys help for mechanical APDL, that's where you will find the theory reference. So that applies to both mechanical APDL and mechanical. But I mean, that has tons of useful information on how Ansys implements certain material models, creep laws, things like that. That's where you'll find all of that documented.
That's really good to point out, because sometimes we're not aware that being a more sophisticated and older program, newer programs just don't tell you what's going on under the hood generally, and it's all there in Ansys.
And of course, not everything is exposed, because there is proprietary technology, but there is a ton of useful information there, as well as references to academic papers, for example, that material models are based upon.
It's a great resource, as is the verification manual, which is, I think, in there as well, where you can actually see in a simplified version for, say, a given element or a given feature.
So there is a verification manual for mechanical APDL, which is all available in the Ansys help. There is also a verification manual for Ansys Workbench Mechanical. However, that one you have to download the example files from the Ansys customer portal, and that's just because the files are as a group pretty large. Yeah, definitely. So there's a lot. And it is useful. So
like we always recommend, when you're learning a new capability, a new feature, just run if there's a verification problem for it, run it. It's a great way to get your head around it in a simple way. Well, that's a little bit of a diversion, but I think an important one. So I'm glad you brought it up. I'm really glad you brought it up. I think we forget that it's there, and new users may not know that those things are available. Good stuff. Definitely attend the webinar and learn more. And as always, feel free, especially if you're one of our customers, to reach out to the tech support group that Ted runs, and we can answer your questions and help you more and get more out of your Ansys investment. So I want to thank you for your time today. In a cold day here in Phoenix, I think it's like 56 outside or something like that. So.
Yeah, we had to put our tortoise in his box in the garage last night. It was cold for him.
I put ours in our den. So he was refusing to go inside, so I had to pick him up, and he hissed at me, and I shoved him in there. So I think we'll probably see him in 4 or 5 months. So
yeah, sounds about right. Well,
that's fun.
Thanks for having me on the podcast, Eric.
Yeah, it's always good to catching up with you, and have a good rest of the week, and we'll talk to you soon.
You too.
Thanks.
Sounds good.
Bye. You can tell that Ted and I actually have a bit of a crush on MAPDL. It's been a constant part of our lives. For me, 34 years, and I think 33 or 32 for him. So you can get a bit attached to even a piece of software over that amount of time. Please do check out more details on this webinar that he's going to be having on Wednesday, November 18th at 11 a.m. Mountain, or listen to it via recording. As always, head over to www.brighttalk.com and search for Ansys and PADT, or Ansys space PADT, or you can go to padtinc.com/events, and you can find it on our events page. Time for our commercial. And for today's commercial, let's talk about mentoring. I'll be honest, I'm not a huge fan of that term, but when we started doing one-on-one support for our customers, that's what the purchasing people called it, and so we call it that now. And the term one-on-one, on-demand Ansys support does not roll off the tongue, but that is what it is. For our mentoring services, we pair one of PADT's experts with you, and you purchase how many hours you need. The engineer is available to help you with your simulation. Sometimes this is a walking through a complex feature in one of the tools. It can also be helping you debug a model that is not converging. Most of the time, it is about leveraging our existing knowledge and experience to get to a result sooner. As an example, your company may ask you to learn, let's just say LS-DYNA to do a drop test on your product. You've never used LS-DYNA, never hex meshed an assembly, and never post-processed a highly dynamic transient event. Our very own Jim Peters will be a call and a screen share away to make recommendations on meshing. Where to simplify, where not to, how to avoid hourglassing, watching the min element size, leveraging some sort of hidden. There's some really good post processing tools that you can use to do the post processing that aren't necessarily obvious, and more importantly, walking you through the model when and not if it massively distorts and crashes 2 milliseconds after impact. Happens every time. Yes, with the help of tech support, you can do this all on your own. And you may have results in, let's say, 8 weeks. With our help, we might get that down to 4 weeks or even fewer. So reach out to Ted's team and let them help you be successful faster. Let's take a look at the Ansys stock. With the election, the stock has been up and down a lot. I don't understand the stock market to begin with, how it reacts to this election. Unfathomable. But anyway, ANSS finished at $328.21 on Friday. This is down from the high of $357.92 a bit over a month ago. They did release their third quarter report, so let's take a look at that instead of comparing to other things. Revenue is up 5% in constant currency when compared to the same quarter, third quarter in 2019. So a nice growth there. Earnings per share are down to 87 cents per share versus $1 per share from the same time last year. They reported strong growth in Asia Pacific. Japan and South Korea especially, they're growing at double-digit rates. So they've pretty much gotten this whole virus thing under control and are just growing like crazy. Also seeing a lot of growth in aerospace. I can definitely say here at PADT, we see the same thing. They basically also set a new record of $880 million in deferred revenue and backlog. So this is money that's going to come in the door. So that's a pretty high number. Let's look at the actual totals, and I'm going to use what they call the GAAP numbers, and that stands for Generally Accepted Accounting Principles. They report both what they use for internal accounting as well as the GAAP numbers. I'm going to use the GAAP because Generally Accepted Accounting Principles just sounds better. Revenue for Q3 was $367 million, and year to date was $1.057 billion for the first 3 months of the year. Profit was at $35.6 million, which is 24.5% of revenue for Q3. And the year-to-date profit has been $218.3 million, or 22.4%. Now, that is down. Last year at this time, the profit margin for the first 3 months was 32, so 24.5 versus 32. But considering that a global pandemic, actually, for the first 3 months is 32 versus 22.4. I got that wrong, read that wrong. So still, pretty damn good for the middle of a pandemic for the majority of those 3 quarters. So definitely something to be proud of. Cash on hand in September 2020 was $845 million. That's down $27 million since the start of the year. And remember, Q4 is when a lot of that cash comes in. So wow, I mean, a great first 3 quarters. Toss in the acquisition of AGI, which is going to be a long-term positive effect. And we talked about that in the last episode, why we feel that way. Things are going well in the financial world of Ansys. So very secure, lots of cash, they're going to be around for you guys in the future, which is what really matters, and money to pay for developers, which is also what matters. So in Ansys news, there's one thing I want to talk about, which is both PADT and Ansys news. An important press release from, it's important at least to those of us here at PADT, came out a few weeks ago. Ansys and Honeywell announced a new strategic initiative for what they call digital transformation. And if you don't know, PADT's founders and many of our early employees, Ted, who was just on this podcast as an example, came from what is now Honeywell engines. In fact, my co-owner, Ward Rand, was one of the first users of Ansys at what was then Garrett. And that's really where all of PADT's Ansys journey began, is when Ward first worked with some other folks there to introduce Ansys as a commercial tool instead of the in-house tools that they were using at the time. This is back in the mid-'80s. So it's really important to us. Honeywell's been a very important customer of ours. We've been very involved with them since the founding of the company. And this agreement just takes it, I was going to say 1 step further, but 10 steps further. It takes the long-term heavy usage of Ansys products in the engines division where we came from and really spreads it across the enterprise and across physics. The goal is to significantly reduce product development cycle time, right? That's what everybody's always after. And we've proven it in parts of Honeywell, and now the whole company is jumping on board. And I'll quote the press release to kind of drive that home. This collaboration standardizes Ansys's full portfolio of high fidelity simulation solutions as Honeywell's common simulation platform across its global organization. So we're very proud of that, to play a small role in the global adoption of Ansys as the common simulation platform. We can't share much beyond the press release. I will read a quote from Suresh, who is the CTO at Honeywell. This agreement will allow Honeywell to drive process improvement and digitization across the company, signifying a tectonic shift in the way our talented engineering teams design new products. This work with Ansys will improve efficiencies, reduce cost, and help our customers get the products they need quicker. So pretty resounding endorsement, and like I said, we're very excited about and very proud to play a very small role in making that happen. So looking forward to the future there. Blog-wise, we've got 2 articles worth mentioning in the PADT blog. Miles, our FlowNex expert, did an article on modeling the flow in a rocket engine using FlowNex. If you have wondered about what FlowNex is and how it can be used, this article is a great example. I found it very interesting, well done, and lots of good pictures that kind of illustrate how things work and how easy FlowNex is to model a very complicated system. Sina also published an article on meshing with the new Ansys Fluent task-based workflow. It's much improved the way Fluent meshing works. It's been a major effort of Ansys Inc. over the last couple of years, is to improve the CFD meshing capability, and this is a giant step forward. We're finding it extremely useful and great reduction in the amount of time it takes to create really good meshes. So check that out if you're doing any kind of CFD meshing, especially if you're using one of those competitive tools that you may have switched to because you didn't like Fluent meshing, and even though everything else isn't as good, meshing was important enough for you to go look at another tool. Come on back and take a look. It's pretty powerful. Event-wise, we're winding down the year. I'll be adding another networking event for the first week in December, so look for that if you're in Arizona and want to take part in our technology networking monthly events now. We're going to keep doing them for a while, I think. I thought it'd be done by now, but there's probably 3 or 4 more left before things get back to somewhat normal at the fastest. So otherwise, we've got a few PADT events coming up. The first is on the 16th, which is tomorrow, Monday, when this podcast comes out, and it's called From Ideation to Approval, Streamlining the Process of Design, Streamlining the Product Design Process. And that is about Stratasys products and how to use 3D printing to get your product done faster. So if you are leveraging 3D printing, do check that out. Then TEDS is going to be on the 18th, Wednesday, MAPDL, Elements, Contacts, and Solver Updates in Ansys 2020 R2. So do sign up for that and listen to it and see more of what we talked about today and some other stuff. And then so far, the last thing we have for the month is a virtual Ansys Mechanical virtual event that Ansys is holding called Level Up. It's kind of like a little mini user group meeting, and that is going to be from 10 to 2 Eastern Time on the 2nd of December. So if you're a mechanical user, I do recommend you check that out. It should be a fun event. And as we all learn how to do these things in a virtual way. So that is it for events, and that is it for the podcast. I want to thank you, everybody, for joining me here in my backyard in Arizona. Mo is still asleep. He obviously wasn't that interested in what I was talking about. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in. And don't forget to subscribe to this podcast. Spread the word. Let other people know that it's out there. And please do not hesitate to reach out to let us know what you think. Thanks a lot. Thank you for joining us for the All Things Ansys podcast, episode 76. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.